It's business. It's business time. Yeah, I know what you're probably thinking. Oh great, another Commodore video. But this is a Commodore with a bit of a difference. Let's take a look. Yep, this is a Commodore 386 laptop, a C386SX-LT to be precise. And looking over on the back, it has a serial number of CA1000282, so I'm guessing it's number 282 in this production run. And it looks like the warranty sticker has already been broken. So I have tried to power on this laptop and it kind of works. Let's take a look at what it actually does. And yes, I have already tested out the power supply, so it shouldn't explode. Well, we have a green power light, so that's a good sign. Let's get this plugged into the laptop, and yes, it has a little mini DIN connector. Pretty sure this only outputs 1 voltage though. 16 volts at 1.5 amps. So this plugs in over on the side here. And there's our power switch. We'll take a look around the rest of the machine in just a moment. Let's just see if it'll still power on. Okay, it's making noise. It's not making happy noise. So it sounds like the hard drive may have crashed, or it seems to be stuck because it is just clicking away. But yeah, the screen does appear to work, although it's not very good. There's definitely some issues. And yeah, turning up this screen, ooh, it just powered off. I think that was from me turning up the screen. So yeah, it does appear to work, at least somewhat, but well, it seems to be stuck now. And we get Diskette Drive 1 seek failure. Obviously the screen on this is very poor, although it is somewhat legible. The problem is, if I try and turn the brightness up, it gets brighter, and then it makes almost like a sizzling noise, and then it shuts off. So yeah, there's definitely some issues with this thing. Sounds like the hard drive is dead, and for whatever reason, turning the brightness up on the screen pretty much shuts down the entire laptop. So something is very wrong inside, dare I say. Now, looking around the machine, we have this panel at the back here, which reveals a printer port, serial port, and RGB, I guess that's VGA output, which is kind of neat. And there's also a ground terminal for whatever reason. Over here we appear to have a slot that's held in by a little screw, so we'll unscrew that in a second. Nothing much doing around the front, and yeah, over on the side, that's actually the contrast control that was causing it to shut down, not the brightness, but who knows with these things. And there's a little hole for a reset button. I can see a little tactile switch in there, and of course a 3.5-inch floppy drive. And that is about all there is on the outside. Now I am seeing that there's 2 sort of clips here. Oh, okay. That removes our battery, which is no doubt long dead. 12 volts at 1700 milliamps, and it is a bunch of NiCad cells. Let's give it a quick test. We're getting 0.6 volts out of that, so it's not bad. And removing the battery does reveal another little panel. There is our lithium backup battery. At least it's actually a lithium cell, so it shouldn't have leaked. I think we can pull that out maybe. Yeah. Hasn't leaked. No doubt it's dead. Looks like it just unplugs, so let's check that as well while we're at it. Yeah, getting absolutely nothing out of that. It also gives us access to another connector back here, which I think is probably going to be going up to the screen, given that they're very fine wires and there is quite a lot of them. And is there a broken clip floating around in there? There's a broken something. What's this little panel for? That's got me curious. I haven't looked under there yet. There is an expansion slot of sorts. I have no idea what it actually is. Doesn't look that familiar to me, but somebody in the comments might know what that is. So, what to do now? Maybe we should try and power it. Where are the So we've got the battery terminals back here. So we should be able to run this off 12 volts, given that's what the battery normally is. See if the screen works or if it's an issue caused by the original power supply, which wouldn't be a big surprise. Positive side of the battery is over here. I'll set the benchy up for 12 volts. Give it a couple of amps. That should make it happy. There you go. Should be right. Let's see if it'll power on. Oh, yep. It's drawing about 1 amp. And yeah, that hard drive, wherever it is, sounds to be making a clicky noise. And we still get diskette drive 1 seek failure. Probably not going to be able to see that on the camera because bloody hard to see it myself. Let's see if we can turn up this contrast. Oh, and once again, it just shut off. It did start to draw about 1.6 amps. I've got the bench set up for 2.5 amps or thereabouts, so definitely not a supply issue. Is it going to power back on? Yep. So yeah, turning up the contrast definitely draws a lot more power, but yeah, it just shuts off after a few seconds. So let's get this thing opened up. I'm guessing that it's not the original power supply. Oh, did I just turn it back on again? So we've got a few screws up the back here and a few screws along here. This looks like it probably holds, oh, maybe that's where the hard drive is up the front here. I don't know. We'll just start taking out screws and see what happens. So these probably hold the keyboard in, I'd say. Maybe that's how we get access to everything else. We'll leave those in for now. Let's just see if that keyboard comes out. Oh, yep. Maybe. There are some ribbons under there, but they look like a decent length. Here we go. Just got to lift those tabs up. There's 2 of them. All right. That's our keyboard out. There we go. There's a part number and a serial number. It's pretty light, but it is supposed to be light, I guess. Feels all right. Nothing special. Nothing fantastic, that's for sure. So it looks like we've got this little flappy shield here, which is held down by a screw up the front. And a couple of screws at the back. And yes, I dare say that's our hard drive sitting under there, and it looks like I will have to take that out in order to get this shield out of the way. Let's see if that helped. Might be able to just slide that. Here we go. So our little hard drive is a Toshiba. No idea what size it's going to be. I imagine it's going to be quite small, probably 20 megabytes or something. But I don't even know if it actually works. It doesn't sound too happy. Well, at least I think that's what's making the ticking noise. So we've got a partial view here, but it definitely extends up underneath this screen part. So let's see if we can get that out as well. Is that enough? Oh, I'll get those screws at the back, I reckon. Yep, this whole thing wants to lift off, but no doubt we have to unplug things. Yeah, definitely that connector at the back. All right, that's those. There's also a big power connector. Probably can't see any of what I'm doing, but that's okay. Right. Put that aside. Now we get a better view of what's going on. So 3.5-inch floppy drive. That's where our little expansion card thing goes in. Whoops. Probably not good for the hard drive, but it's probably car anyway. Over here. Oh, that is an 8387, so that's our math coprocessor, which means this would be our 8386 running at 16 megahertz. There's an AMD EEPROM here, so I'm guessing that's our BIOS. These guys here, probably memory. Yeah, they're an MCM 51L4256AZ80. Mouthful. So it sounds like they're 256 by 8 bits. So in a 16-bit machine, that would give us, let's see, 1, 2, 3, 4. So a whole 1 megabyte on this board. And it looks like there is possibly an option to expand that here, but it is unexpanded in this machine. Chipset looks to be from Oak Technologies. They all say OTI 051, 52, 53, 54, 55. There is also a Sanyo chip here, not exactly sure what that is. And WDC, I'm guessing that's the floppy disk controller. And probably that little chip there, maybe that's read-write amplifier for the floppy drive. I don't know if that's normally built into the floppy drive. Could be something else. And of course, a couple of crystal oscillators. And it looks like we've got a little power supply board over here with a bunch of electrolytic caps. And it looks like these purple ones might be polymers, so don't have to worry about those ones leaking, but definitely these ones could be suspect. So given this thing cuts out when we try and boost up the contrast, let's take a close look at this power supply. So over here we've got the mini DIN connector, which is where our power supply brick plugs into, and of course our on-off switch. And this looks like it just connects everything to the main board. This, I think, goes up to the battery connectors, and this goes over to the screen. Apart from that, we've got a little choke, a bunch of electrolytics, a couple of resistors, what looks like a diode package there, and no doubt a couple of MOSFETs here. There's a little fuse there. Obviously, that must be intact, I dare say. But yeah, these electrolytics down here, just looking around the base of this transistor here, I can see a little bit of gunk down there. Yeah, so it almost looks black around that base, but it's also shiny at the same time. Oh yeah, and that is definitely some kind of liquid. What's a bet it's from one of these guys? So dare I say what's happening is when we turn the screen up, it's obviously drawing more power from this power supply, and the electrolytic caps are crapping out, introducing more ripple, and that's probably making it back to this sort of feedback circuitry, and the power supply says, nope, something's seriously wrong, time to shut down. So I don't think it's really worth probing this or scoping it out. I think we just get straight in here and start getting these old caps out, because they are definitely shot. So to get this out, it's obviously a couple of screws that have got to come out. All right, there we go. That's a little bit more of that. It says modem under there, so I guess that's for a modem card of some sort. Are these screwed down? No, they are not. Ooh, we may be able to sneak this out without actually having to take the main board out. The connector's sort of upside down, but I reckon we can get just enough. There we go. Ew, yeah. The underside does not look great either. So I'd say these guys are leaking, and that's even managed to make it to the underside of the board, and yeah, that's not good. But luckily it doesn't look too bad. Nothing we can't handle, I don't think. So I might just make a note of what capacitors we've got here and their location. In terms of height, because these are pretty shallow, I think we'll be okay, because these sit pretty much under the keyboard, and there's definitely plenty of room in between there. So although the caps on this are quite shallow, shouldn't matter if I have slightly taller ones, because yeah, these short ones might be hard to get. Right, so our electrolytics, we've got 3 50 volt 10 microfarad caps and 4 25 volt 33 microfarad caps. I'm not so worried about the polymer caps right now. I might just test them in circuit maybe, see what they read. Let's get these electrolytics out first, and I'd better make sure that I've actually got replacements. Well, it looks like I've got 3 of the Nishikons and 3 of the unknown brand. Let's just quickly test them, see which one might be better suited for this circuit. So I'm going to take a guess that there is some high frequency switching going on this power supply, so I'll set the meter to 100 kilohertz and we'll just jump over to ESR. Let's see what the Nishikons test like. Right, at 100 kilohertz, the Nishikons are around 5.6 microfarads with an ESR of 1.2, so perhaps they're not very suitable for high frequency stuff. Let's see what the other ones are like. Well, that's looking better. 8.57 with an ESR of 0.01. So they appear to be more suited to high frequency stuff. Even though I don't know the brand, we're going to go with them. Let's see about 33. So we needed 4 of them at 25 volts. Looks like we've either got some Kemet caps, 33 mic, 25 volts, 105 degree rated, ESH series, I think, and these look like they're Panasonic Matsushita, 85 degree rated. I'm guessing M series. Plenty of both of these, so let's just do the same test. Alright, the Panasonics don't even read at 100 kilohertz. Let's see what these ones are like. And they're coming up at close to 20 microfarads with an ESR of 0.56, so not ideal given that it's supposed to be 33 microfarad rated. I'm guessing if I test this at 100 hertz, it'll look a lot better. Yeah, 31.45, but the ESR has gone up. And they should still easily fit underneath that keyboard. So let's get this old stuff out, clean up the board, check for any damage, and get the new caps in. Right, so our caps are all around this area, and yes, they have bent the leads over. Thank you very much. Ooh, and there's a trace nearby that might have some damage to it. Definitely have the smell of leaky caps, and some of them really struggle to come out. Struggling to get some of those holes clear, no doubt because the old electrolyte has leaked and mixed with that old solder. Probably also take out these two transistor looking things. Are they the same? No, that's a 7812, that's a 7912, so plus 12 volts and minus 12 volt regulators. It's definitely very crusty under them, so got to take them out too. Alright, that's our area cleared. Probably should remove this little polymer as well, just because it's very close by. It should be fairly easy to get out, as long as the corrosion hasn't made its way under there as well. Just throw on a little bit of vinegar, see if we get any reaction. Nope, nothing too exciting going on with this one. Let's flush off that vinegar with a bit of IPA. Alright, see if we can clean out these crusty holes. I'll just throw a little bit of flux over there and we'll try it with the desoldering braid. Alright, that took a few passes with flux, solder and braid, but I think we are all clear, and I don't mind spending a little bit of extra time doing that if it means I avoid needing to do any trace or pad repairs. Alright, I'm pretty happy with that. There is just one little trace coming off one of the legs of the old capacitors here, which seems to lead up to this resistor here. Yeah, so I'm seeing about 1 ohm resistance on my leads at the moment, and across this trace we see, yeah, 0.9, so that's perfectly fine. So all we need to do now is get the new capacitors in. The lead spacing is a little bit smaller, so I'm just going to set them a little bit off the board, not a big deal. So far so good. Now for the components that we took out, better just test these before we put any of them back in. Potentially we might have to replace some of these as well. Let's start off with this little polymer cap. So the legs on it still look okay-ish. Test at 35 microfarads at 1 kilohertz with an ESR of 0.4 ohms. So yeah, I think that's still fine for a 33 mic 10 volt cap. Let's see what one of these old ones tests like. So on this one we get 2 nanofarads with an ESR of 14.7 kilo ohms for a 33 microfarad cap. So all the old caps tested below 2 nanofarads with ESRs in the tens of kilo ohms. And yeah, these little voltage regulators, the legs are covered in gunk and it's getting all over my fingers. That is disgusting. So because these are probably seeing some pretty harsh voltage spikes, I'm just going to replace them. I'm not going to put those old ones back in. And thankfully, I do have 7812 and 7912. The new ones have a slightly smaller case, but I'm pretty sure these are all the same current rating. They're all 79L12, 78L12. And now just the remaining polymer. I reckon all of these should be fine, given that they don't have a electrolyte in them that leaks out. I don't see any issues, and this one was closest to the disaster site, and it survived just fine. Oh, and we can't forget our inductor. All right, I think we're good. Let me get this back in the machine and we'll give it another try. Right, the machine has been loosely reassembled. I just put a couple of screws in to stop it trying to fall apart, and I did realize that I have to bend these caps over a little bit in order for the keyboard to fit properly, because the leg spacing wasn't quite right. So they sit a little bit out of the board, and then they also sit too tall if they're upright. So there's just enough clearance, I think, if they're bent over a little bit. That should be fine, so let's try and power this thing up. I'll use the bench power supply again, just in case anything goes wrong, and see what happens. All right, smoke test. That hard drive definitely isn't happy. Well, nothing's caught on fire. I don't see anything on the screen though. Oh, here we go. All right, let's see if we can turn up this contrast to the max. Yes. It seems to have a lot more range to it now, which is a good sign. And the power supply is sitting at about 900 milliamps all the time. So that, I think, is a good sign. And yeah, at the right contrast and brightness level, it's not actually that bad. I mean, I'm looking at it on the side and I can still clearly read everything that's on the screen. I'm not sure if the camera's going to pick that up, but there is sort of like almost like a dirty screen effect at certain levels. So maybe there's still some more bad caps in the screen itself. I don't know, but at least it seems to be stable. Just a shame about the hard drive now. Oh, okay. So I hit F1 to continue, and now the hard drive is making a horrible clicking sound. Oh. And when I powered it off just then, a very grindy sound. So I think the heads have crashed and probably marred up the disk. So I'd say that thing is more than likely cooked. I guess we can open it up and have a look at the carnage inside, assuming I can get it open. Yeah, let's do that. In fact, I wonder if somebody's already opened this up. Warranty void if seal is broken, and yeah, that's definitely been broken. Well, at least we're not going to void the warranty on it. I think that's it. Let's get in a bit tighter. Let's see. Doesn't look too bad, at least on this disc. I wonder if one of the lower heads is broken off and is scratching up one of the platters, although looks like it might only be a single platter in there. I don't know, maybe we should just power it on like this, see what it does. I mean, it's already broken anyway, so can't really break it anymore. See if it tries to jump out of the machine. It's not making any horrible noises anymore. It also doesn't seem to be doing anything. Yeah, it's not returning the heads back or anything. So I think that's where it was sitting before. So the heads have completely come off. And it's just like scratching up the side of the disc. So if I just breathe on it, you can see that what looks like scratches in there. So yeah, I think it probably died quite a long time ago. Let's see what happens if we hit F1 to continue. It just, okay. Yep, that's not what's supposed to happen. And that's what that grinding noise is. So I've thrown the lid back on the hard drive, but when I did that, I actually noticed that there are some electrolytic capacitors on the bottom. These are like the ones that you'd find on a Sega Game Gear, and yeah, they're prone to leakage. They're basically through-hole capacitors in this square sort of case that's just glued to the board. So maybe I'll just swap them out just for fun. I mean, this hard drive is already kaput, no doubt. It's already been opened before, and I opened it again and breathed on it. So it's probably not going to be super reliable, but maybe we can actually get some signs of life out of it. So let me find some replacement caps. We'll just swap these out, see what happens. Alright, so what I'm going to try and do is just clip the leads off, and then I can just rip the capacitor shell off the board. Just like that. And then I'll just come in and tidy up those pads. Oh yes, and it even smells like recapping a Sega Game Gear. They have definitely leaked. Alright, there we go. It's not pretty, but it doesn't need to be. And as for these things, so yeah, they pretty much should be able to just kind of pull out of these cases. I think they push out from the bottom. Here we go. That's all there is to them. We'll give them a quick test. These are supposed to be 100 microfarads. 78, but ESR, yeah, about 7 ohms, so very leaky. They're either really low capacitance with a high ESR, or they're around the right capacitance, just with slightly raised ESR, but yeah, either way, these are all shot. Alright, here we go. Quick test, see what happens. Wouldn't expect too much, but maybe we'll be surprised. We'll just sit that there. Alright, let's just go F1 to continue, see what it does. Oof. The exact same thing it was doing before. Those caps did not help. How about a listen to that grindy noise when we turn it off? Ouch. So, never mind. The hard drive is definitely cooked. I'll just replace it with probably a compact flash card, and that'll be that. One thing I am still curious about is whether there's bad capacitors in this screen as well. I noticed one of the little covers here popped off and disappeared on the bench somewhere. There it is. So I'm guessing there's another screw behind here, and might be a couple of covers up there. So maybe if we undo those, we can have a look at what's behind this plastic panel. Just kind of sit it like that. That should be fine. Okay, so little driver board for our LCD panel. There is one electrolytic cap on there. Wonder if there's a bunch more behind the panel itself. Ooh, and a little bit of rust in that corner. If I just take these screws out, I might be able to just sort of flip the screen over and take a look on the back. On the back, there is a whole lot of little, LCD matrix driver chips. They're all Oki branded. And that's about it. A little bit of standard logic in here, and a few, I guess, tantalum caps. But yeah, I wouldn't expect any of these tantalums to be bad, otherwise they probably would have exploded already. So yeah, nothing much else to see here. Everything looks above board. And again, made by Sanyo. So I'm starting to think this machine is probably entirely made by Sanyo and then just branded as Commodore. So here's our little driver board, nothing much to report. Oh, there's actually 2 electrolytics, and they look very similar to the ones that were on the power supply, so I think we should pop them out, give them a test at least. It's a 22 microfarad, 25 volt. Yeah, it doesn't look too bad. 21 microfarads, 2.6 ohms ESR at 1 kilohertz. Let's see what the other one's like. This is a 4.7 50 volt. Yeah, 4.4 with an ESR of 6.3 ohms. So I guess we can swap those out as well. I've got a 4.7 mic 50 volt. Yeah, it's got an ESR of about 1 ohm. 0.13. Now, there's not a lot of room in here, so I'll probably just have to fold these over a little bit. Right, that'll do. I'll throw this all back together, give this screen a bit of a clean while I'm at it, and see if it made any difference at all. Power on. Right, well, looks about the same there. And yeah, at a certain level, we still get that sort of dirty screen effect. What can you do? Shut up. Well, I guess that's going to be it for this video. The machine appears to work, at least it seems to be functional. Obviously the hard drive is dead, so we need a replacement for that. And I need to, I guess, cobble together some kind of boot disk so we can take a closer look at what this machine is capable of. I imagine it's not going to be much, but yeah, apart from that, I have some ideas, maybe replacing the screen with something else. I'll obviously look into getting a new CMOS battery, and I don't know, maybe try and crack this thing open and see what's inside. But I don't want this video to go on too long, so I think we'll end it here, and that'll give me time to do some more research on this particular machine. So yeah, leave any thoughts or ideas in the comments, and of course, thank you all for watching, and a huge thanks to the people that support the channel on Patreon. Like, share, subscribe, all that crap. I will catch you in the next one. Bye. Yeah. There are no screws.